Today on Capechi's Corner, we're going to look at logarithms and logarithmic functions. So what is a log or a logarithm? Basically, the easiest way to explain it is it's an exponent, it's the answer. So basically what we have here, we've been graphing this. If we do the inverse and we exchange the variables, what happens is the exponent becomes the inverse of the exponential function. Okay, so I know that's a little bit confusing, so we'll go through it kind of step by step. Now, there's some examples that we have here, and we're just going to get used to exchanging things into different forms. So if I start with in log form, and we're going to put it into exponential form. Okay, so in this, we would say, for this example up here, we would say log base 3 of 27 is equal to y. Then 3 to the y power is equal to 27. So the answer here is really the exponent. Okay, so what we're going to do in number 1, we're going to write it in exponential form. So our base here, right, we say log base 2, that's our base, that's our big number. The answer becomes our exponent, and then the other number in there is 8. So 2 to the third is equal to 8. And number 2, again, this little number is our base, right? We say log base 4. Our exponent is our answer, is 1 over 256. Do the same thing with number 3. Our base is our big number. Exponent is equal to 1 over 100. Okay, so now again, we're going to change it and do it the other way. We're starting in exponential form, and then we're going to write it in log form. Okay, so we're going to write the word log. Again, our big number, right, we say that's our base. So our base is going to go down there. Log base 15 of 3,375 is equal to, and our answer is our exponent 3. Same thing for number 4. Log base 4 of 2 is equal to 1/2. In number 6, we have log base 125 of 5 is equal to 1/3. Okay? All right, so evaluate. The word evaluate, remember in math, means to give it a value. Okay, so I'm going to set that equal to y just to make it easier visually. So I want to solve for y. Okay, so basically right here, right, that's our base. 16 is our base. Remember, our exponent is our answer, and that's equal to 4. Now, we've done a lot of this, in the last chapter, so we want to get our bases the same. So probably the easiest way is I can get 16 to have a base of 4 as well. So 4 to the second power 16 raised to the y is the same as 4 to the first power. So 2y is equal to 4. And, sorry about that. 2y is equal to 1, not 4. I'm looking at our base. 2y is equal to 1. Divide both sides by 2, and y is equal to 1/2. All right, let's look at the next one. So we have, again, that's equal to y. So 3 to the y power is equal to 81. The base you want to use is 3. So 81 is 3 to the 4th power. So y is equal to 4. Let's look at number 9. Again, set that equal to y. So we have 1/2 to the y power is equal to 256. Now again, we want to get to base 2. That's going to be our easiest number to deal with. So we have 2 to the negative 1 power, right, raised to the y is equal to 2 to the 8th. So I have negative y is equal to 8. So y is equal to negative 8. Okay, these you get better at them with practice. Okay, all right, let's look at some graphs now. Now, remember, this is the inverse of an exponential function. So we want to actually kind of work backwards in a way. So we're going to go through step by step. Here are some examples. At the top, you can see what they're basically going to look like, just a general parent graph. So when we graph the function, the first thing we're going to do is we're going to set it to exponential form. Okay, so remember the f of x is like y. So this gives me y is equal to the log base 5 of x. So 5y is equal to x. Now we're going to make a table. What's different about these is I'm going to pick points for y to find x. Usually we pick points for x to find y. So we're going to still send my xy table up. But I'm going to pick some common numbers that I like to use, at least to get started, and I can go from there and substitute it in. So when y is 0, x is 1, y is 1, x is 5, and then I start to get some fractions, 1 over 5 and 1 over 25. And now I'm going to plot my points. So I have 0, 1, 1, 0, 5, 1, and then I have 1/5, 1/5, negative 1, and then 1/25 negative 2. So I'm going to really, really go close to that y-axis, but I'm not going to touch it. And there's my graph for that log. Okay. All right, let's look at the next one. Same sort of idea, same steps. I'm going to set this equal to y is equal to log base 1/3 of x. So 1/3 gets raised to the y power, and that's equal to x. I'm going to set my table up, but remember I'm picking values for y. So I'm going to do 0, 1, negative 2. I'll do 2 on this one too, just to see where it goes. Okay. So 1/3 to the 0 power gives me 1. That gives me 1/3. If y is negative 1, that gives me positive 3. Then I get positive 9 and 1/9. And again, if you want to go a little slower, you can always pause this and go back. Okay, so I have 1, 0. X is 1, y is 0. I have x is 1/3, y is 1. X is 3, y is negative 1. X is 9 down here, and then y is negative 2. And then we have again 1/9 and we have 2. So same sort of idea. We're going to get this general shape. We're not going to cross that y-axis. And there we go. Okay, great job with log functions today. Have a good one.